So now in this video, I thought it'd be a good time to go over the 100 ohm resistor there. So there's the schematic symbol. I'm just kind of indicating that we got power across it. This means there's like a measurement at that point for the current. You don't actually have to measure the current. If you see this, maybe it's just letting you know what the current is going. And so in this case, the current that you'll see at this point will be the supply voltage across the resistor, or whatever the voltage is across the resistor. It may not be the total supply voltage. We'll come back to that. But if it is the supply voltage right there, that's the voltage divided by the resistance, 100. So if it's 1 volt divided by 100 ohm, I didn't actually write it out here, but you'll have 0.01 amps of current, which is the same as 10 milliamps of current. So you got 1 volt, 10 milliamps right there. Now, wattage is important too. So this is a 100 ohm resistor. If you look at the color code, that means plus or minus 1% right there. But 100, and then no more zeros. Whereas the 1000 ohm, which we looked at in the last video, for the multiplier has a brown band. The way I like to think of it is that's one more zero, or you could say times 10 for this. This would be times 1. And then there's the 10,000 ohm resistor, which I just happened. I usually have one quickly able to catch right there. Red band for 2 more zeros right there, or times 100. But in any case, this is the size of a quarter watt resistor. You can see how small it is right there, very small. And 0.25 watts. So that's the absolute maximum. Any other value resistor that's this size will still be a quarter watt resistor because it's the size. It's how much surface area it has. More surface area it has, the more heat can come off of it in different areas. So it won't warm up as quickly or to as high of a temperature as this one will right there. So that's the absolute maximum though. You still want to stay below 0.125 watts. So when I entered these numbers into the diagram, that's where I stopped, you know, just right below 1/8 of a watt right there. So now, if you look at this diagram, you notice we can get a fair amount of current for a little component like this going through the resistor, about 35 milliamps of current, more than what a LED will. The LED will have a really short life if you do 35 milliamps of current. You want to stay below 20 milliamps of current for a red LED. I mention that because that's one of the main examples I use for a current setting resistor. It's a common use in my circuits right there. But you can see 1 volt, 10 milliamps is 0.01 watts. It's actually volt times 0.01 amps equals 0.01 watts. I put milliamps there for some reason. And last video I did the actual amps right there, but did milliamps there. Just remember this is a 0.01 amps, or that. If you got 2 volts, it's going to be 0.02 amps. So that's not what's written up there, but this is more of a visual. Equals a 0.04 watts. So 2 times 0.02 is 0.04. That's 4 times as much heat going to be generated by a 100 ohm resistor if you got 2 volts across it instead of 1 volt. That's the main thing. Put 3 volts across it. Again, 0.03 amps that you multiply it to, multiply it with, I should say. Then you got 0.09 watts. So that is 9 times hotter at 3 volts than the resistor would be at 1 volt. Wattage goes up really quick, and we couldn't even go to 4 volts without exceeding 0.125. So we stopped at 3.5 volts. But the thing is, you can get about 35 milliamps of current going through it. So, you know, that's, you know, kind of high for just a small circuit where you would use a resistor, like quarter watt resistor. But you know, you can get a fair amount of current. Not a whole lot of voltage across it though. So you got to address that. One way is with series components. So this is not a 100 ohm resistor. This is a circuit that I cover a lot right there, protecting a red LED from 5 volts. I usually say probably best to use about 220 ohms of resistance or more. Higher resistor will just equal less current. But we're going to look at the basic principle here. If you have 5 volts at the supply, red LED is going to drop about 2 volts, leaving about 3 volts across the current setting resistor right there. And so that'll give us about 13.6 milliamps in this example. Now let's imagine we drop this down to 3 volts. Red LED is still going to drop about 2 volts, leaving about 1 volt across, in this case a 220 ohm resistor. So this would be about a third of the current right there I think a little bit more than 4 milliamps of current. Red LED is not going to be very bright. You really kind of want to exceed about 10 milliamps of current for them to like really light up. Like 4 won't be too bright. So you could use a 100 ohm resistor. You got 1 volt across it. It's going to be about 10 milliamps of current. So won't be as much as you kind of want for a red LED, but probably will be acceptable right there. If you put a 100 ohm resistor there, 3 volts, 100 ohm resistor, there'll be 1 volt thanks to the 2 volt drop. And you'll have about 10 milliamps of current. And it's pretty easy. I did the math down there for 3 volts, 220. But it's really that easy to, once you are familiar with this, to swap those numbers out. I pretty much just did that on the fly. I didn't have to think about it too much. 3 volts total, 2 volts will be dropped, 1 volt there. Pretty simple. And so if I want 10 milliamps of current, I know 100 ohm resistor should be swapped right there. Because LEDs don't set the current, they just drop some voltage. If that's all in circuit there, LED and resistor. Resistor will set the current based on the total voltage that ends up across it. Because the red LED is going to drop about 2 volts. And so yeah, that's why it's good to get familiar with this sheet. As I said before, if I have 100 ohm resistor, I know we're going to get 10 milliamps for every volt. So yeah, in any case, hopefully that all made sense. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.